Shifting gears, we're going to talk about simple things having to do with EPSPs, IPSPs, and resting membrane potential. So if we're talking about resting membrane potential, you need to remember that it can be set up by three things. One thing that it needs to have is the sodium, potassium, ATP, ACE. And that is going to kick out, 3 sodium and bring in 2 potassium. There's also going to be 2 potassium leak channels. And that's going to allow potassium to leave 3 negatively charged proteins. Okay. What that does is it makes it so that there is a whole lot more sodium on the inside and a whole lot more potassium, or sodium on the outside, potassium on the inside. Okay. And what that also allows is makes it so that sodium is going to want to go into the neuron and potassium is going to want to leave the neuron. That means that we can open up different types of channels and then things can happen. So if we open up a sodium channel, it's going to go into the cell. Same thing with calcium, magnesium, I think it's 2+, and a variety of other different types of positive ions. If we open up a potassium channel, it's going to leave. Or a chloride channel, chloride is going to go into the cell. This is going to create either an IPSP or an EPSP. IPSPs are going to be negatively charged, and EPSPs are positively charged. So bring things closer versus bring things further away. I means inhibitory, E means excitatory, PSP, postsynaptic potential. You can have either an IPSP or an EPSP get triggered by those types of channels that I talked about in the last part of the video. That's what we're going to talk about right now. Super quick overview of what's going to go on with this whole entire business. This is a neuron. This is how action potentials are going to function. Generally, we're going to start out with either an EPSP or an IPSP. Once again, EPSP is going to be positive, IPSP is going to be negative. So let's say that we have some sort of positive thing that is going to come into the cell. That means that positive is going to make it so that it is more positive inside of the cell and within the soma of the neuron. What we're looking for is we're looking to hit this magical threshold. So if we have our resting membrane potential and then we have an EPSP, that's going to be a positive. An IPSP is going to be a negative. So we have our positive, we have our negative. If we have enough positives and negatives that all end up making everything so that everything is super positive, then that means that we can, so the negative can either go in or can be positive leaving. So potassium leaving. So what eventually we're going to want to have is enough of these positives to hit a certain threshold. So this is threshold at the axon hillock. We have voltage-gated sodium channels and potassium channels. And remember, potassium is going to leave, sodium is going to enter, that are going to open at the axon hillock, which will then cause a triggering of events that makes it so that we have this positive going in, which is going to spread positivity. It's going to leap across where the myelin sheath is, and then cause more voltage-gated channels to open, which is going to make more positive, which is going to make more positive, which is going to open up calcium channels on voltage-gated calcium channels, which means that calcium is going to go in. That calcium is going to make its way over to synaptic tethering proteins, which is going to cause them to contract, which will make it so that the vesicle will release its goodness into the cleft. And that releasing of the goodness, that is going to be some sort of neurotransmitter, and that is either going to be a positive or cause a positive or a negative type of reaction in the next cell, whatever that cell may be. So it can either be a neuron as I've drawn it, or it could be a muscle. If it is a muscle, then the neurotransmitter is going to be the nicotinic acetylcholine receptor, which is a ligand-gated sodium channel. And then that will cause cross-bridge cycling to occur. We'll talk about that in a different video. As we're doing this whole entire thing, to make sure that, so we've talked about this positivity bit. That is going to be these voltage-gated sodium channels that are going to be opening. Slower than that are this negative bit, which is voltage-gated potassium channels. Voltage-gated potassium channels are going to make it so that potassium is going to leave and leave and leave. So it is going to bring everything back down, and it's actually going to overshoot. So repolarize and then hyperpolarize and then go back to resting. This is partially because of inactivation of the sodium channels after they have opened. So after they close, then they're going to inactivate so that everything goes back to normal. And that is an action potential.